For today's presentation, we're going to talk about the gravimetric determination of the percentage sulfur as sulfate in fertilizer. And these are our four presenters. So, as an introduction to this presentation, I will first define the gravimetric analysis, since this presentation is to determine the percentage of sulfur in fertilizer using the gravimetric analysis method. To define the gravimetric analysis is a method which is highly scientifically significant in society. When this method is used effectively, this method is particularly important to determining the exact percentage composition of items such as foods or in this case fertilizer, so that producers can meet the stringent labeling laws of their particular industry. If you are aware, fertilizer products are prominently labeled with three numbers, usually stated on the front of the package. These numbers specify the relative content of the chemical elements NPK, which are nitrogen, phosphorus, and potassium. Those chemical elements are found in the fertilizer, and this label is known as fertilizer grade and is a national standard. For example, a bag labeled with 10, 10, 10 indicates that the fertilizer has 10% of nitrogen, 10% of phosphorus, and 10% of potassium. So, in this presentation, we will explain to you how the percentage of the sulfur in fertilizer can be determined through the gravimetric analysis method.
So this part will explain the theory of sulfur in fertilizers. The first focus here is importance of sulfur in plant nutrition. Sulfur is an essential nutrition for plants playing a crucial role in the production of vital compounds. It is a fundamental component of amino acids, which are the building blocks of proteins. Additionally, sulfur is necessary for the synthesis of vitamins and the formation of chlorophyll, the molecule responsible for photosynthesis. The second focus here is sulfur as sulfates. Sulfates represent the predominant form of sulfur in fertilizers. They exhibit high water solubility, making them readily accessible for uptake by plants. Common sulfate-based fertilizers include products such as ammonium sulfate and potassium sulfate. The last point here is preference for sulfates. Sulfates are favored in fertilizers due to their immediate availability for plant uptake. The ability to dissolve rapidly in soil moisture ensures that plants can absorb the nutrition soon after application, facilitating efficient nutrient.
Before we move on to the procedure and the calculations, I would like to talk about the applications and also the importance of gravimetric analysis in daily life. So, gravimetric analysis is a quantitative method that is widely used due to its precision and also accuracy in measuring the amount of a substance in a sample based on its mass. Some of the important aspects of gravimetric analysis includes its versatility. Gravimetric analysis can be adapted to measure different substances and concentrations, which makes it very versatile across different fields. Another aspect is its reliability. When executed properly, gravimetric analysis yields reliable results that are less prone to interference from other substances in comparison to other quantitative techniques. And in terms of standardization, gravimetric analysis provides a standardized method for comparing data across different laboratories and also studies, which ensures consistency in measurements. Moving on to a few examples of the application of gravimetric analysis in daily life. So the first one is environmental monitoring. Gravimetric analysis is crucial in environmental studies to determine the pollutants in air, water, and also soil. For instance, measuring the particulate matter in air quality assessments involves collecting air in filters and then using gravimetric analysis to determine and quantify their mass. Other than that, gravimetric analysis is also commonly used in the pharmaceutical industry. So in the development and also manufacturing of drugs, the accurate measurement of active ingredients and also contaminants is absolutely crucial. Gravimetric analysis helps to ensure the purity and also the potency of pharmaceutical products. In the food industry, gravimetric analysis is employed to determine the composition of food products. For example, it can be used to determine the fat content in dairy products and also determining the mineral concentrations in nutritional supplements. Last but not least, in forensic science, gravimetric analysis is used in investigations to determine the composition of trace elements or substances found in crime scene.
Hi, my name is Marissa, and for my part, I will explain about the procedure and the example of the result of this analysis, which is gravimetric analysis of percentage of sulfur as a sulfate in a fertilizer. In the first step, 1.2 gram of the fertilizer was weighed. Thereafter, a 5% of weight-to-weight barium chloride was added into a sample of fertilizer. So this solution was added very slowly to allow formation of so much bigger and easily filtered precipitate. So this process are called as a preliminary treatment and the precipitation of precipitate. So, however, just a side note, if this precipitant form is still small in size, we need to undergo a digestion process. So in this digestion process, small precipitate form need to be put into a mother linker a certain period of time, allow a formation of so much bigger and larger precipitate. In the first, at the third step, which was the filtration process, this precipitate will be filtered by using a suction filtration. Then the precipitate need to undergo the washing process in which the precipitate was washed with a few aliquots of hot water. However, in this step, it need to be conducted very, very carefully to prevent any peptization of the precipitate. After that, the precipitate need to be dried inside of the oven in which the temperature was set to be 110 degrees Celsius. So the temperature must be hot enough to remove all the water adhering, but also must not be hot enough to decompose all the crystal or the precipitate form. This is called a drying process. Lastly, the dry precipitate of a barium sulfate was weighted and the percentage of sulfur can be calculated as the following below by using a gravimetric factor. At the end of the experiment, the mass of barium sulfate precipitate was estimated to be 0.2387 grams. Next is the example of the calculation of sulfur inside of the barium sulfate using a gravimetric factor. So the formula of the gravimetric factor is the molar mass of sulfur need to be divided by the molar mass of barium sulfate. And since both of them share the same number of mole, which is 1 mole, so both of them need to be divided by 1 mole. The molar mass of sulfur is 32.1 will be divided with the molar mass of barium sulfate, which is 137 gram over mole. The result is 0.2343. To determine the mass of sulfur, we can times the gravimetric factor with the barium sulfate precipitate weighting form. So the 0.2343 of gravimetric factor will be times with 0.2387 gram of barium sulfate precipitate, and the result is 0.0559 gram of sulfur. Lastly, to find the weight per weight percentage of sulfur, we need to divide the mass of sulfur with the weight of sample. So the 0.0559 will be divided with 1.2 gram times weight 100%, and the result is 4.66% of sulfur as a sulfate in fertilizer sample. In conclusion, the gravimetric analysis is a powerful method that is often used to determine the amount of desired analyte based on its mass, this including the amount of sulfur in a fertilizer. Based on a journal by Dania on 2023, she mentioned that the theory of gravimetric analysis of sulfate can be carried out by weighting and precipitation, which means it is accordance with the general understanding of the gravimetry, which is a way to analyze the substance by weighting and precipitation. This method is suitable to use in a various fields, including the environmental monitoring, the industrial process control, and is widely used in the food industry.
And here are our 13 references that we use to collect the information for this presentation.